In this video, we solve the system of non-homogeneous equations by using the Gausss Seidel iteration method. So before going to see that how to find out the solution of a Gausss Seidel method, we learn the concept of diagonally dominant system. So consider the system. So I am taking here only three equations. That is a11 x1 plus a12 x2 plus a13 x3 equals to b1. So consider the system. Now we need to check that whether this is diagonally dominant or not. So we have to check only for the diagonal elements. So the diagonal dominant are considered as what? So here the diagonal coefficients are must not be 0, and when compared to the other coefficients in the given equation, it should be large. For example, you see that the three equations are given here. Now you see that the diagonal element in this equation, the diagonal a11, so that is 10. This 10 is greater than the other coefficients of y and z. And now if I come to the second equation, so this here, this is not a diagonal element in this case here. So this is greater than the other coefficients, but it is not a diagonal element. So we need to rearrange these equations here. So to make it rearrangement, we'll write it as what? 10x plus y plus z equals to 12, and 2x plus 10y plus z equals to 13, plus next 2x plus 2y plus 10z equals to 14. Now we can see that this 10, the quotient of x 10 is greater than the other quotients of y and z. In this case, the diagonal elements, all the diagonal elements here, they are larger than the other coefficients in each equation. So this is considered as a diagonally dominant. Now we see that the Gausss Seidel method, how to find out the solutions of the Gausss Seidel method by using the iteration method here. Okay. So now we need to consider the system. First we need to check that whether they are diagonally dominant or not. Okay, if they are diagonally dominant, then only we need to proceed the system to find out by using the Gausss Seidel method. Okay, and if it is diagonally dominant, we need to write the diagonal dominant element should be equal to. Okay, that is, now in this case, in the first equation, the dominant is a11. So write down x1 as the variable x1 equals to 1 by a11 b1 minus a12 x2 minus a13 x3. Similarly, in this, the a22, the x2 quotient is dominant, so write down x2 equals to. In this equation, x3 is the quotient of x3 is dominant, so write down x3 equals to. And next, so for the, while finding the solutions or iteration, so initially we need to consider the approximation. So we are writing this x1, this is an initial approximation, x2 initial approximation, x3 initial approximation as 0. In all the cases, we need to consider the initial approximations as 0, start from 0 itself. Next, we will come to the first iteration. So this is the first iteration. So in the first iteration, write down x1 as this is the first iteration. So substitute in the previous equation, that is, so write down now here. So whatever the initial approximations you know here. So x2 initial approximation, x3 initial approximation. So we'll get the x1 first approximation value and x2 first approximation. Now we need to write that here. So whatever the approximation we got it in the first approximation, that should be used at a next instant, so that it should be filtered and we'll get a resultant value. And the x3 first approximation obtained as, already you know that x1 first approximation, x2 first approximation, substitute both of the equations so that we'll get a filtered value or iterated value here. So similarly, we'll get the second iteration by substituting these first iteration values. So we'll get the second iteration. So continue this process until we'll get a desired approximation, and the two approximation, we need to see that any two of the approximations should be same here. So successive two approximations should be same. Then we'll stop the iteration method and we'll conclude that that is the solution of the given system of equations. Now let us learn an example how to solve the system of non-homogeneous equation by using the Gausss Seidel iteration method. Okay, first we need to check that whether the system of equations are diagonally dominant or not. So the equation 1, so the x quotient is 10 and the other quotients are 1 1. So that means, so here a11 modulus is must be greater than a12 and a13. So now that is 10 is greater than 1 plus 1. So that means the equation 1 is diagonally dominant. So dominant, only diagonal elements we need to see that. So the second equation now, so y coefficient. So a22 is greater than a21 and a23. So that is 10. The 10 is greater than again 2 plus 1. And next, if I see the third equation, a33 is greater than a31 plus a32. So that is a33 value is 10 coefficient and greater than a31 2 plus 2. So it is 10 is greater than 2. Now you see that all the diagonal elements here, a11, a22, a33. So these are the diagonal elements, they are greater than the quotients of the other. So therefore clearly we can say that the given system is diagonally dominant. So in that we see that they are clearly diagonally dominant. Now if it is write down the diagonal dominant coefficients, that is a variable x equals to, x can be written as what, 1 by 10 times of 12 minus y minus z from the first equation. And in the dominant second equation, y is the dominant, write down the variable y equals to 1 by 10 times of 13 minus 2x minus z. And then in the third equation, the z coefficient is dominant, so we can write z equals to 1 by 10 times of 14 minus 2x minus 2y. Now let us consider the initial approximations. The initial approximations always we need to consider it as a 0. Initial approximations here, approximation of x initial approximation equals to y initial approximation equals to z initial approximation. We are going to consider them as zeros. So we'll see the first approximation. The first approximation is obtained for x, the x equals to, we'll write 1 by 10 times of 12 minus, so we need to substitute the already known values, that are what, so y and z initial approximations are known, so right here y naught, so initial approximation z of initial approximation, and substitute those values here. So those values are 1 by 10 times of 12 minus, so y and z approximations are 0, so which is equals to 12 by 10, which is equals to 1.2. So now we'll see the first approximation of y. So that is y first approximation equals to 1 by 10 times of 13 minus 2x minus z. Now substitute the values already known here. So what are the known values here? X value. So x is already, it is equals to 0 in the initial approximation, but it is modified as now x1 as initial approximation as what now? First approximation. Substitute the refined value, that is x1 value, and we don't know the z value of first approximation. So that therefore we need to use the previous value, that is initial z value. So which is equals to 1 by 10 times of 13 minus 2 into x first approximation is 1.2 minus z initial approximation is 0. So finally we'll get the value as 1.06. Now we find the z approximation, first approximation, which is equals to 1 by 10 times of 14 minus 2x minus 2y. Now we need to substitute what type of values here? So already known values, so that is refined values here, that is first approximation of x and first approximation of y. Substitute those values here. 1 by 10 times of 14 minus, so first approximation of x is 2 into 1.2 minus y is 2 into 1.06. So on calculating, so we'll get 0.95. This is the way to find out the first approximation. The second approximation. So right here, x second approximated value equals to 1 by 10 times of 12 minus y minus z. Now use the known values of y, that is first approximated value, and z first approximated value. So which is equals to 1 by 12 times of 12, 10 times of 12 minus y value 1.06 minus z value 0.95. So on simplifying, we'll get it as 0.999. Next, y second approximated value equals to 1 by 10 times of 13 minus 2x minus z. Now write down the known values. Now we have to write the second approximated value and previous value, that is first approximation value, which is equals to 1 by 10 times of 13 minus 2 into second approximated value of x, that is 0.999 minus z is previously, that is first approximation, 0.95. So on calculating, we'll get it as 1.005. Next, we'll find the z second approximated value, so which is defined as 1 by 10 times of 14 minus 2x minus 2y. So here already known values, that is second approximated values of x and y second approximated values of x we should use. So 1 by 10 times of 14 minus 2 into second approximated value of x, 0.99 minus 2 into second approximated value of y, 1.005. On simplifying, again we'll get it as 0.999. So these are the second approximations of the given system of equations. So after the first approximation, second approximation, we'll see that we need to check that x values, when it is compared with only x values, x comparison, so it is 1.2 and it is 0.9. So it is going to converge. So 1.06 and 1.005. So 1.06, 1.00605, they are going to converge here. Similarly here also 0.95 and 0.99. So the convergence is going to be obtained. Okay, now we'll see the third approximation. The third approximation is of x, y and z. So third approximation of x can be written as, so x third approximation equals to, it is defined as 1 by 10 times of 12 minus y minus z. Now we need to use the previous second approximated values, y second approximation value and z second approximation value. So they are 1 by 10 times of 12 minus y second approximated 1.005 minus z second approximated is 0.999. On calculating, so we'll get it as 1.00. Similarly, find out the y third approximation, that is 1 by 10 times of 13 minus 2x minus z. Now we need to use the third approximation of the x value and z second approximation value. Substitute those values here. 1 by 10 times of 13 minus 2 into third approximation of x, 1.00 minus z second approximated is 0.999 equals to, it is also 1.00. Next, z third approximation value, so 1 by 10 times of 14 minus 2x minus 2y. Now we have to use the third approximations of x value and y value. Substitute those values. 1 by 10 times of 14 minus 2 into third approximation of x, that is 1.00 minus 2 into third approximation of y is 1.00. On calculating, we'll get it as 1.000. So finally, we'll see the comparison of first, second and third approximations and we'll conclude the result. Now we'll see the comparison of second and third. So you see that second approximation of x is 0.99 and third approximation of x is 1.0. So this is nearly equal to what? 1.00 only. And similarly now 1.005 of y second approximation and third approximation of y. So which is also equal to nearly equal to 1.00. And if you see the z third approximation value is 1 and here second approximation value is 0.9. So nearly equal to 1. So now with this we will conclude that the approximations of second and third are similar according to our desired approximation. So therefore we will conclude the solution as. So with this second and third approximations we conclude the solution of the given system of non-homogeneous equation, that is x equals to 1 and y is equals to 1 and z equals to 1.